Good afternoon, everyone. Today we will discussion about the example of the differentiations and L'Hopital rules. And my name is Wan Yu and my material number is 232081.
My name is Chen Yu. My metric number is 231,829.
My name is Zhang Bohao. My metric number is 231989.
My name is Zhu Yongqi. My metric number is 226558.
My name is Cui Yuhan. My metric number is BC254541. Okay, I'm going to explain question 1. A, B, C. First, I take the derivative of the function. The derivative is x squared plus x minus 6. Then I set the derivative equal to 0. After solving the equation, I get x equals minus 3 and 2. Next, I use the second derivative to find the relative extrema. The second derivative is 2x plus 1. When x is minus 3, the second derivative is negative, so this point is a relative maximum. When x is 2, the second derivative is positive, so this point is a relative minimum. Then I look at the sign of the first derivative. When x is less than minus 3, the derivative is positive, so the function is increasing. When x is between minus 3 and 2, the derivative is negative, so the function is decreasing. When x is greater than 2, the derivative is positive, so the function is increasing again. That's all for my explanation.
So let's talking about the question 4a. We are asked to evaluate limit sine 3x over 4x. First, as x approaches 0, so the numerator sine 4x and the denominator 4x approaches 0. Therefore, this limit is in the denominator from 0 over 0, so we can apply L'Hopital rules. Next, we differentiate the numerator and the denominator. The derivative of sine 3x is 3 cosine 3x, and the derivative of 4x is 4. After applying L'Hopital's rule, the limit becomes limit 3 cosine 3x over 4. Finally, we make the x equal to 0, so we can get cosine 0 equal to 1. So finally, we can get the value of the limit is 3 over 4. Thank you.
For example 2, two parallel sides of the right angle are being lengthened at the rate of the 2, while the other two sides are shortened in such a way that the figure remains a right angle with the contact area A is equal to the 50. What is the rate of the change of the perimeter P when the length of an increasing side is? Question A is 5, question B is 10, question C. What are the dimensions when the perimeters cast to decreased? This is the solution. So first, let the length of the increasing size be x by x and the length of the decreasing size by b. Because we know the area is equal to the 50, so x multiplied by the y is equal to the 50. and y equal to the 50 over the x. The perimeter of the rectangle is the p equal to the 2x is the 2y. So we get the p is equal to the 2x is the 100 over the x. And find the rate of the change of the perimeter. We first know the y is equal to the 50 over the x, and we know the dx over the dt is equal to the 2. So we get the dy is over the dt. It's negative is equal negative to the 100 over the x squared. Now we get the final formula is the 4 reduce the 200 over the x squared. So we look at the question A. When the x equal to the 5, we get this formula is the 4 reduce the 200 over the 5 squared. Its answer is the negative 4. So we get the answer. The negative things. In this case, the perimeter is decreasing at the 4. Now we look at the question B. When the x equal to the 10, it is the same principle in the question A. We get the 10 into this formula. We get the answer A is a 2. So the positive things. In this case, the perimeter is increasing at the 2. Now we look at the question C. We know when the dp over the dt is equal to the 10, the perimeter stops the decreasing. So we let the 4 reduce the 200, and 200 over the x squared is equal to 0. The perimeter stops the decrease. So we get the x is equal to 5 square root 2. So the answer is the figure at the square with the side length is 5 square 2.
Okay, for question 3, we have 2 questions. The one is asked to maximum total profit and a relative minimum. For part A, we should find the revenue function Rx equal x times px equal x 50 minus 1 per 2x equal 50x minus 1 over by 2x squared. For step 2, we need to find perfect function px equal rx minus cx. Px equal 50x minus 1 over by 2x squared minus 1 per 4 times x squared plus 35x plus 25. Px equal minus 3 per 4 x squared plus 50x minus 25. Step 3, differentiation to minimize px. Set p parameter of x equals 0. Then we can get x equal 10. Okay, for part B, we verify minimization. The second derivative of AC with respect to x, and then we get x at 10. So when x at 10 at x equal 10, AC double parameter 10 equal 50 per 10 cubed equal 50 per 1000 greater than 0. Since AC double parameter 10 greater than 0, the function is concave up, then confirming a relative minimum.
So let's talking about the question 4a. We are asked to evaluate limit sine 3x over 4x. First, as x approaches 0, so the numerator sine 4x and the denominator 4x approaches 0. Therefore, this limit is in the denominator from 0 over 0. So we can apply L'Hopital rules. Next, we different the numerator and the denominator. The derivative of sine 3x is 3 cosine 3x, and the derivative of 4x is 4. After applying L'Hopital's rule, the limit becomes limit 3 cosine 3x over 4. Finally, we make the x equal to 0, so we can get cosine 0 equal to 1. So finally, we can get the value of the limit is 3 over 4. Thank you.
Okay, so for the second example is to find the limits of the 3e to the power of 2n over 4n squared as n approach infinity. For this one, it gives the infinity over infinity, so we can use the L'Hopital rules. You will have the differentiation, first differentiation. After the first differentiation, you will become limited 6e powers to the power of 2m over am. But it's still of the infinity over infinity form, so we need to use the second differentiation. So it will become limited 12e to the powers of 2m over a. As the m approach infinity, the answer is infinity. So for the three example to find the limit of the s squared time to the natural logis of s as s approaches 0 from the right. So it will give the 0 times negative infinity. So which is an determination for we can rewrite as a natural rows of the logos of s over s to the power of negative 2, which is infinity over infinity. So we can apply L'Hopital rules. After differentiations, we can get 1 over s divided by negative 2 s to the power of the negative 3, which includes negative s squared over 2. So as the s approaches 0, and this is approaches 0, so the answer is 0. For the last example is to find the limit of m times e to the power of 2n as m approach infinity. As n approach infinity, both m and e to the power of 2m approach infinity, so their produce also approaches infinity. So it doesn't use the L'Hopital rule.